Hi, and welcome to this session on transformations of graphs. Now, this session is applicable for both GCSE and A-level students. This content appears in both syllabuses, and I will be going through everything you need to know for both. There is complete overlap in this lesson. So whether you're a GCSE maths or an A-level maths student, this session is going to be applicable for you. Now, a reminder, there are accompanying worksheets to go with each of the sessions. And the link for those is in the description of the video. So let's get started. Transformations of graphs. Now this is when graphs are shifted left, right, up and down, reflected in the x-axis or the y-axis, or stretched one way or the other. And we can write this in a number of different ways. There are a few that we need to know. So let's run through them, and then I'm going to show you them on a graph so that it all makes sense. So if I have the graph y equals f of x, the first two transformations we're going to look at are y equals f of x plus some number, which we don't know what it is, we're going to call it a, or y is equal to f of x plus a. Now, the first one, have a guess. Y equals f of x plus a. What will that transformation be? Hopefully, you'd have guessed that that moves the graph up by a. Or if I want to write it in vector notation, then I can write that as 0, a. So it moves the graph up by a. What about if I have the plus a in the bracket? Now, the rule is if it's in the bracket, it affects the x-axis. So up is at the y-axis, up and down y, left and right at x. And x is also the one where everything is opposite. So if it's in the bracket, it's x, and x equals opposite. So instead of going plus, you'd assume it gets bigger. We actually are going to go left by a. So it always does the opposite of what you expect. Or if we write it as a vector, it's minus a 0. Sorry. Now don't worry too much about jotting these down, because also as part of this video, there is a free revision card / poster, depending on how you want to use it, containing all of these transformations that you need to remember. So it's more important that we understand them during the video rather than trying to remember them. So those are our left, right, up, down transformations, they're translations. Two more that we need to know are stretches. So if I have y is equal to a f of x, or y is equal to f of ax. Outside the bracket means it's y, so this is a stretch in the y direction by a. So it's going to make it longer. It's going to stretch my graph out. And we'll see this when we come to an example. By a. If it's inside the bracket, it means it affects the x. So it's going to be a stretch in x by, remember, we're timesing, so we do the opposite. So we're going to divide. So it's by 1 over a. So if I double my graph, I actually stretch it in by a half. So it becomes almost a compression. It's the opposite. Final two that we need to know and remember are the reflections. So there is a reflection in the x-axis and a reflection in the y-axis. If I have f of minus x and f minus f of x, the top one is a reflection in the y-axis, which means the x's swap over. And if it's minus f of x, it's a reflection in the x-axis. And again, you will see this when we do an example. So let's have a go at our example. Now, drawing a graph on here is notoriously difficult, so I have pre-prepared a graph. But what I would love you to do is to pause the video and have a go at doing this yourself, and we'll work through it together. So could you have a go on your paper at drawing the graph of y equals x squared plus 2x minus 3? Have a go. It's a nice quadratic, so you're expecting a nice happy face. Have a go at drawing y equals x squared plus 2x minus 3. Pause the video, have a go at that. I, however, have pre-drawn it, so let me share that with you. Sorry, I just paused for a second then. Let me pre-share that with you now. There we go, it's there. Couldn't find it. So there we go. Hopefully yours looks a lot like this. We've got the graph of y equals x squared plus 2x minus 3. Remembering we need to label on the important points, so where it crosses the axes, so at minus 3 and 1. It has a minimum, which you might not have got, but it does have a minimum at minus 1, minus 4, and it crosses the y-axis at minus 3. We're now going to have a look at some transformations of that graph, and you are going to tell me what has happened in each transformation. So the graph in red will always be the original graph. So the graph in red is still y equals x squared plus 2x minus 3. So what has happened to go from the red original graph to the green graph? What transformation has happened? Well, hopefully you've realised that it's moved 1 to the right, which means if we had to write that, the transformation of this graph would be f of x minus 1. That is moving our graph 1 to the right. Don't worry if you didn't get that. This is why we're going through it nice and slowly. So how would I get from the red graph to the blue graph? Have a think. Well, the answer is that my graph has moved up by 3. And so that would be f of x plus 3. We can see that because the minimum down here has moved up 1, 2, 3 spaces. And these points here have moved up 1, 2, 3 spaces. And so everything has shifted up by 3. Excellent stuff. Okay, let's have a look at the next one. Again, the graph in red is the original. I've just moved the graph down a little bit because it's all very stretched out and I couldn't fit it all on the screen. So have a go. What do you think the green transformation is? What do you think the green transformation is? And if you've got that, what do you think the blue transformation is? Hopefully, pause the video if you need some more time. Hopefully you've had a go at those. So if we were to describe what's happened for the green transformation, we have stretched the graph horizontally. And so this would be y equals f of 2x, because it's stretched in by a factor of a half. The minimum has gone from -1 to -0.5. This point here has gone from -3 to -1.5. And this point here has gone from 2 to 1. I've stretched all my x coordinates in by a factor of 2. And so that would be y equals f of 2x. For the blue graph, I've stretched it vertically. I've pulled my graph downwards and out. I can see that the minimum has doubled. So it's gone from -1, -4 to -1, -8. So that's doubled out. Notice that the points where it crosses the axes haven't changed though, because they are at y is 0. And so that would be y is equal to 2 f of x. Excellent stuff. Brilliant work. So final example is of our reflections. Have a go at what you think the green and blue graphs would be. So the green graph would be y is equal to f of minus x, because I've reflected it in the y-axis. It's the x coordinates that have swapped everything round. And so that would be y equals f of minus x. Whereas the blue graph would be y is equal to minus f of x, which is my reflection in the x-axis. So I flip the graph in the x-axis. And there you have it. That is our transformations of graphs. If we can remember how to do all 6 of those transformations, that will stand us in good stead for this topic. If you have any questions or comments, leave them in the box below. But otherwise, have a go at the worksheet, and I will see you for the next session. Take care, guys. Bye.